So now we'll start a subject about unification. Well, unification is quite a simple subject. We just want to, we have two formulas. For instance, P, we have an X and then an Fy. And we got a formula P with a constant A and an F, G, Z. So how can we make this formula be the same? How can it be the same? How can we let them look alike? So we do this by substitution. This is a variable, so x can change in everything. So as we see in this location, P over here is an A. So we can substitute x with A. Over here you see Fy, and we see Fgz over here. So y is a variable. The function f is not a variable, so we cannot change that, but that's not a problem over here. So we can replace y with gz. So a formal notation for this is theta is, and then, well, we want to replace x with a and y with gz. So gz y. So now this formula will look like exactly this formula. Well, I'll give another example. Now we got a q, a function q, and there's an a, comma g, x, comma a, comma f, y. And we have another q, there's an a, and we got a g, f, b over here, comma a, comma x. So we want to let this formula look like this formula. We want to unify them. So, well, we already see the first part of the formula, this one, they equal. So that's not a problem. So we got an x over here and we got fb over here. So if we replace x with fb, they will equal each other. But now we see that there is also the same x over here. So the rule is that this x will also change into fb. Well, that's not a problem, because x will now be fb over here. So I'll do it. We replace it with fb. So, well, this part of the formula looks like this part, so that's not a problem. But now we have fy over here. So y is a variable, so we just have to replace b. We have to replace y with b, and then they will look alike. So theta is, well, fb with x, and then y, b with y. So our new formula will look like g, and then f, b, comma a, comma f b. Now I will give you an example where unification isn't possible. So we got an R, we got an HX, and we got a C over here, and we got an R, we got an FA, we got a Y over here. So now there is no substitution possibility for X that can equal make HX and FA equal each other, because the H won't change over here. So when you replace with X for FA, you get HFA. So you get HFA. And that doesn't equal. So in a previous example, with P X, F Y and P A, F G Z, we found a substitution by substituting X with A and Y with GZ. But there's also another substitution. For instance, we can substitute, well, we just substitute X with A, so that's not a problem. But we can substitute Y with GB, for instance. And the only thing we have to do then is substitute Z with B. This is also a valid substitution, but we're now going to look for the most general substitution. So the most general unifier. So Martelli and Montanari, they designed an algorithm for that. Martelli and Montanari. Now I'm going to explain the algorithm to you. So, well, the algorithm states that we need to put our equations. So we got one formula T, and we got the other formula U, and we want to see if there is a most general unifier with them. So, we're just gonna enter them, and if T looks like F, ft1 till tn, and U has the size F U1 till UN. It's really important that this is the same N. So N and M are the same, so that T till Tn are the same size, as many as U till UN. So if it has the same size, you can break open the equation and you can compare T1 with U1 and finally Tn with Un. So that's the first part of the algorithm. Second part of the algorithm states that if T is of the form T1 till Tn and U is of the form G U1 till UM. This is an M, not an N. So it states over here that if G does not equal F, or n does not equal m, if one of those two cases isn't true, then the algorithm fails. And there is no most general unifier. So if n and m have the same length, but g doesn't equal f, then the algorithm fails. If g equals f, but n and m don't have the same length, the algorithm fails. And if they don't have the same length and g doesn't equal f, then the algorithm fails. So the third part of the algorithm is that if you finally get x and x, so if they are exactly the same, you can remove them from your list. So remove and continue. Okay, well, the fourth rule is quite silly. If you got a formula that looks like this, T1 till Tn, you can switch them around. So you have to switch them around. That you get f T1 till Tn, so that machines can understand it. So, if it has the form ft1 till tn x, and x is not a part of these terms, then you can replace everywhere except this place. You can replace x with this function. So replace x with f g1 till tn. This can also be a constant, so you can also have an a or something. It doesn't matter. Okay, well, the last part of the algorithm is that if you have the comparison between f till t1 and till tn, and x is a part of these t's, then the algorithm fails. You don't have an MGU, Most General Unifier. So I'll give you a little example on this algorithm. It's one of the previous examples. So we got Q, and we have an A, and we have G, X, comma A, comma F, Y. And we have the other one, that's Q, it's an A, and we have a G, that's F, B, comma A, comma X. So, according to the algorithm, we need to put this in brackets. And we are going to compare it. So the first step in the algorithm was look at the outer formulas. So they have the same Q. And now we have to count the number of elements inside. So we have 1, 2, 3 elements over here. And we have 1, 2, 3 elements over here also. So now we can use the first rule of the algorithm. We can compare T1 to U1 and T2 to U2. So I'll do just quick. FB, comma A, and we compare FY to X. So, well, does the first part of the algorithm apply to this? No. Well, we'll skip the other rules. I already see that the third part, the third rule of the algorithm applies for this, because it has the shape x equals x or AA. So we can delete this out of our equation. So we'll get the new equation gx, comma a, g fb, comma a, comma fy x. So now we're going to look again at rule 1. Well, we see that we have a function letter and they both have the same size, they have the same function letter, so we can apply the new rule, and it was that we can break it open and we can compare x to fb, and we can compare a to a, and we can compare fy to x. I hope I'll stay with enough space over here. So okay, well, then we get to the fourth part of the rule, and it was quite a silly one. So I'll put it over here because of too low amount of space that we have to put the x on the right side. So we have FB over here. We have A, and we have F, Y, X. So now we ended at the fifth part of the algorithm, because we see we have a function letter over here and we have an X over here, and X isn't part of any of the elements of F. So we can substitute every X with FB. So that means that we need to replace this X over here with FB. So let's do that. We have FB, A, and we have FY, FB. Okay, so we can move on to the next, to AA. Well, the rule is simple again, they equal each other, so we can just delete that one. So we can delete this one, and we have FY, FB. So if you look at this rule, you see that we can break open the F, because F is the same over here, is the same as this one, and it has the same size. So our new formula becomes F be x, and this is y, this is b. So we can apply one more rule, and it's the silly one, that we can switch y and b. So we get b over here and y over there. And then we're finished. And as you will see, it's the same as the answer as we had in the previous example, only without the general unification algorithm.